Now in this video, we are going to take up one more problem on projections of lines. The problem reads as a line has one end 30 mm in front of VP and 15 mm above HP, and the other end is 15 mm in front of VP and is above HP. The length of the line is 60 mm. The top view of the line is 40 mm long. Draw the two views of the line and obtain the inclination of the line with HP and VP. So here he has given that one end of the line is 30 mm in front of VP and 15 mm above HP, and he has given the other end is only the top view. He has given the distance, or the top view locus is given, and he has given the true length of the line and top view of the line is given. By considering this, we should be able to get the locus of B, or the locus of B in the front view, and also to find the front view length and the true length in the front view. So to do that, how to analyze this by using 3 dimension? So here, one end of the line is 15 mm above HP. You can see this is the distance above HP. So this distance can be seen from the front view. When you look from the front view, you can see that the line is projected till here onto the vertical plane. So you mark that point as A dash and you mark this as capital A. So you have 15 mm above HP, and it is in front of VP. In front of VP distances can be seen in the horizontal plane. So by looking from the top view, I can see the distance of the point A is in front of VP by 30 mm. So when it is projected, when it is viewed from the top view, it has been projected on the horizontal plane, and you mark this point as small a and capital A here. Then the other end B is 15 mm in front of VP. You can see the distance in front of VP. When you look from the top view, it will be on the horizontal line. So you measure the distance from the XY line to 15 mm and draw a horizontal line, which will going to be the locus of B in the top view. And also he has given the top view distance, which is B, that is 40 mm. So with A center, taking a radius of 40, cut it on the locus of B in the top view. So he got the point B, and also he has given the true length of the line. The true length of the line in the top, the true length of the line is 60 mm. So since you know the true length of the line, and you know the locus of B, so inclination you are going to get automatically. With A center, taking the radius of 60, cut an arc on the locus of B, and you mark this point as B1, and you are going to get this as capital B. Since it is the true length in the horizontal plane, that line will going to be parallel to HP. So what will going to be the position of the point both A and B1? Both A and B1 will be above HP by 15 mm. So that can be seen only when you look from the front view. I can see the distance above HP by 15 and also the above HP by 15 in case of B1. So when you look from the front view, that line is being projected into the vertical plane with A dash, which is capital A, and also you project this point from B1, so it will be onto the vertical plane, and you mark that point as B1 dash. So then you are going to have A dash, B1 dash is the line which is parallel to HP. Since it is parallel to HP, so you are getting the true length in HP. So this is the one which we are talking about. You are going to have capital A and capital B in the top view. Now, how to do this by using, by drawing it from the manual sketch. First, we will going to draw the XY line, and you mark VB and HP. Then from XY line, you measure 15 mm above HP, so you draw a horizontal line. Similarly, from XY line, you measure 30 mm and draw a horizontal line. And take any point from the vertical plane, from here, you draw a vertical projector such that it will going to cut both the lines of the horizontal line. Both in VP and as well as in HP. So then you mark this point as A dash and you mark this point as small a, and this as capital A in the front view and this as capital A in the top view. And he has also given the distance in front of VP, the other endpoint B. So in front of VP can be seen in the horizontal plane. So from XY line you measure 15 mm below the XY line and draw a horizontal dash dot line. And since it is the other endpoint B, so you mark this as the locus of B. And he has also given the true length and the top view line. So the true length and the top view line of the point B will going to lie on the locus of B in the top view. So by using the compass with A as center, taking a radius of 60, cut an arc on the locus of B, and you mark that point as B1, and then join between A and B1 with a little bit thicker than the XY line. So you mark this point as capital B, you mark this point as B1. Then he has also given the top view distance with A as center, take a radius of 40, and you cut an arc on the locus of B in the top view. So you mark that point as small b, join A to B with a dark line. So this is how you will be able to plot whatever the data which was given has been transferred into the orthographic view of the drawing. And now as we rotate the horizontal plane down, so this will going to come below the XY line. Now, how to project this? How to get the front view now? How to get the front view? You know the distance, you know the top view distance. Once you know the top view distance, so the front view of this point B should lie on this end projector. So what you do? You draw a vertical projector from here to here, and then from again you draw one more vertical projector in the vertical plane. So this will going to be the distance between the end projectors. So this will going to be the distance between the end projectors of both A dash and B dash, or A and B. So now what I want, the front view of the point B dash should lie on this vertical projector. So where exactly this point is there at present in the front view of B? The front view of point B is above HB by 15 mm. But actually the front view of the point B is not above HB by 15 mm, such that the radius of this will going to cut this particular radius somewhere on this line, so that will going to be the point of the front view. But now this is how you will be able to analyze the front view. So why you are getting this as the front view? Because the front view I will be getting only from the front view of the true length. You know, this is the top view true length in space, and when it is projected, this will going to be the true length in the vertical plane. What does it mean? It is the true length in vertical plane, the true length in the horizontal plane. That is basically because both A and B1 are above HP by 15 mm. So as we look from the front view, so you are projecting that point directly onto the horizontal line drawn from A dash. Both A dash and B1 dash will going to be at the in front above HP by 15 mm only, because then only the line will go to become parallel in the front view. You know that this is the true length in the top view because its front view is is parallel to XY line. So this is how you will be able to analyze this front view from the true length of the top view. Now how to do this in an orthographic view? So you draw a vertical projector from B to the front view, and we know this is the true length in the horizontal plane. Since we know that this is the true length in the horizontal plane, obviously that in the other view, so this is the top view of AB1, the other view of the top view of AB1, that is the true length, will be A dash B1 dash. You know that this is the true length in the front top view because its front view line is parallel to XY. So that means both B1 dash and A dash should be above HP by 15 mm. But that actually the front view point, so this is how you will be able to get the front view of this particular drawing. Now the next thing is how to get the front view now. So what I need to do, with A as center, taking the radius of AB1, which is the line which is in space, you start rotating in counterclockwise direction such that the line drawn from the end projector of the point B will going to cut this arc at this particular point, which I will going to call this as capital B. So this will going to be rotated till it will going to touches the locus of B in the front view. No, that is basically because we don't have the locus of B in the front view, as we are rotating this till to the end projector line of this in space. You can get this point here, which is capital B. So as we look from the front view, this end projector distance from above HP, whatever you have here, the same thing will going to be there here. So obviously, when you are rotating in space, this point B1 which was here will going to cut the end projector point drawn from the top view. So when you look from the front view, that point B is projected onto this vertical end projector. So this point will going to become B dash, then join A dash B dash with a dark line. Then again, now we have the locus of B in the front view. So you mark this point as locus of B and you mark this point as B dash, and of course you have A dash and capital A. So once you do that, how do I be able to write it in orthographic view? So as we have drawn the vertical projector from the B to the front view, and similarly you know that this is the true length in the horizontal plane, that means it should be parallel to HP. Where is parallel to HP? That A dash and B1 dash both are above HP by 15 mm only. In other words, the front view line is parallel to XY, then in the corresponding top view, AB1 is in true length. Now, with A dash as center, taking the radius of A dash B1 dash, you draw an arc such that it will going to cut the end projector line drawn from the point B from the top view. So this vertical projector and this arc will going to intersect at this point. And you mark that point as B dash and join A dash B dash with a dark line. So this will going to be the locus of B in the front view. So you have to then this is the apparent inclination with respect to HP. So therefore you will going to get it as alpha. Now similarly, I want to get the front view true length. How to get the front view true length? So to get the front view true length, I should make the top view line parallel to XY. Which is the top view line? Small a and b. A is in front of VP by 30 mm and B is in front of VP by 15 mm. But what actually I require is both A and B is equidistant from the vertical plane. That means A is in front of VP by 30 and B1, and similarly B2 also should be in front of VP by 30 mm. Then only the line will going to be parallel to XY. So what I can do is, with A center, taking the radius of capital AB, you draw an arc, you rotate that line in space such that both capital A and B2 are in front of VP by 30 mm. So now the line is parallel to VP. So as we look from the top view, you can see that image is also being get rotated. With A center taking the radius of AB, then draw an arc such that AB2 are in front of VP by 30 mm only. Now the line is parallel to VP. Since the line is parallel to VP, so you are getting the true length in VP. How to obtain that? So here, as we rotate it in space, what happens to the image? That line which was there from here to here has been rotated till here, where you are going to have AB2 is the line which is parallel to XY. Once you get this point, then by looking from the front view, this B2 projector will going to be falls on the locus of B in the front view. So you mark that point as B2 dash and join I dash and B2 dash with little bit thicker than the XY line, and you mark this as capital A and you mark this as capital B. So this is how you will be able to analyze the drawing in 3 dimension wherein you have a true apparent inclination with respect to HP and VP, true inclination with respect to HP and VP. So this is how you will be able to analyze the drawing. Now, how to write it in orthographic view now? So actually what we have done, we have got this. Now what I want to find the true length in the front view. Since I want to find the true length in the front view, I should take the top view line parallel to XY, which is the top view line AB. With A center, by taking the compass with AB as the radius, you draw an arc such that both A and B2 are equidistant from the vertical plane, which is 30 mm. So in front of VP is always seen in HP. Where is HP? HP is below XY line. So you are getting that point AB2 now here. Now AB2 is the line which is parallel to XY in the top view. Therefore, the corresponding front view in true length, you can see the corresponding front view is A dash B2 dash. Then join A dash B2 dash with little bit thicker than the XY line. And you mark this as capital A and you mark this as capital B. And this will going to be the locus of B. So what is the so this is how you will be able to analyze this. Now how do I know that my drawing is right? Even after doing that, both B and B dash will going to lie on the same line. You know that A dash B dash is the front view because its top view line AB is inclined. You know that A dash B2 dash is the true length line in the front view. Obviously in the top view that line should be parallel, that is AB2 is parallel to XY. Similarly, you have a true length in the horizontal plane, that is in the top view. Therefore, to find the true length in the front top view, you must have the line parallel to XY in the front view. So, take the front view line A dash B2 dash, A dash B dash and draw an arc. Then you are going to get the line A dash B1 dash is the line which is parallel to XY in the front view. Therefore, you are getting the true length in the top view. Then you, by holding the protractor, you measure the angle of true inclination with respect to VP and also the true inclination with respect to HP. That is theta and phi. Theta will be 48 degree, phi will be equal to 15 degree. And similarly, the apparent inclination with respect to HP and apparent inclination with respect to VP. So with respect to VP is beta and with respect to HP is theta. So the beta angle when you measure from A to B1, so that will going to be the true inclination with respect to VP, which is phi, which is 14.48 degrees when you are doing it in computer, but when you are doing it in manual it will be 15 degree. And similarly, the true inclination with respect to HP is theta, which will go to be 48.19 when you are doing it in computer, and when you are doing it in manual it will be 48 degrees. Similarly, the apparent inclination with respect to HP, which is alpha, which is the extreme line, which is A dash B dash, so that will be equal to 50.34 degrees or 50 degree. Similarly, the true apparent inclination with respect to VP, which is beta. So from A, with reference to this horizontal, you measure the angle beta. So the beta value is 22.02 degree. When you are doing it in computer, when you are doing it in manual, it is 22. So how do I know that, the final conclusion is, how do I know that my problem is right? So when the top view line is parallel to XY, AB2, its corresponding front view will be in true length, that is A dash B dash. A dash B2 dash. Similarly, you know that this is the true length in the HP because its front view line is parallel to XY. And you know this is the front view A dash B dash because its top view line is inclined. You know that this is the top view because its front view line is inclined. So this is how you will be able to analyze the drawing and do the drawing manually by using the sketchbook. What is the final takeaway? Both the points of B and B dash should always be lying on the same plane. Thank you.